Hey students, tonight we're going to take a look at the SAT Practice Test 11 that was released by College Board around the middle of February 2026. I'm going to start off by looking at Module 1. Not all of the problems in Module 1, but I'm going to look at some of the ones that maybe I found a little bit unique and different than maybe what you've experienced on other practice tests with the SAT. And then I'll move into Module 2 and do some of the more difficult problems there in Module 2. Here's the first one that I want to look at in Module 1. It says, which quadratic equation has exactly one distinct real solution? Well, if you go about solving this by the square root property, you would square root both sides. Now, this answer right here is going to be my answer, it looks like, because if I square root both sides of that equation, I'm going to get x plus 15 equals 0. And then I do have one solution and one solution only. That's going to be negative 15. Now, answer B, I'm going to get actually no real solutions because when I square root both sides, I will get an imaginary or complex number. Therefore, this one can't be the answer because there are no solutions. And then these two are going to not be the answer either because when you do square root 45 and 135, when you square root both sides, you will get two answers because this will be plus or minus the square root of 45. Here's one that might typically be missed on Module 1. This is a very classic kind of question where they are lumping in the first 3 hours that you are paying for this bus within a fixed fee of $950. So you have $950 that you would have to pay for the first 3 hours, and then every hour after that, you would have to pay $50 per hour. But again, only after the first 3 hours. So one way to think through how you would construct this equation is to think about it this way. What if I were to go in and say rent the bus for 7 hours? How would I expect to be charged? Well, I would only expect to be charged for 4 hours at $50 an hour because the first 3 hours are going to be charged including the $950. So I would expect to be charged $950 plus the $50 per hour, but only for 4 hours because the first 3 hours were included in the $950. Now, where did this 4 come from? It came from the fact that I was taking the total 7 hours minus the first 3 that were included over here. All right, so what this really means is that I need to put a t minus 3 right here. Because remember, they're saying when we are renting for more than 3 hours, so that if I am going to rent it for, say, 4 hours, it's going to be $950 plus 50 times just 1 hour. And so this is going to be the equation that goes with that particular scenario that they've given us. I did want to quickly mention problem 14. You can use what we call regression in Desmos. They're giving us 4 values, and they do tell us it's a linear function. It shows 4 values of x and their corresponding values of g of x. And they say it can be written as this. What's the value of b? Well, they want me to find b is the y-intercept. And I can very quickly see that my slope here looks like it's going to be a negative 4 because as my x's are going up by 1, my y's are going down by 4. So if I back up to 0, then that would mean that would have to be 36. So I really don't need to use regression on this if I notice that since the x's are lined up 1, 2, 3, 4, I can see that the y's keep going down by 4. That means if I back up to 0, I go back up by 4 to 36. Now, if you did want to use Desmos, sure, you could do regression and type the word table and then put the ordered pairs in. Now, I only need 2 ordered pairs to make a straight line, but we'll go ahead and put them all in. And then what we can do is we can click this button right here to add the regression, and it's going to give me negative 4x plus 36. There you go. D is the answer. I definitely want to show you this one. This is number 15. The way that I would recommend solving this is different than what is recommended if you look at the solution that College Board has posted for this. It says that the population of the town of Smithville doubled every 75 years from 1659 to 1959. And it says the population of the town was 240,000 in 1959. What was the population of this town in 1659? So they want me to go back 300 years and get that population. Well, hopefully you recognize this as an exponential function. When something is doubling every so often, we want to write it as an exponential. But what I'm going to use is my initial value in 1959 of being 240,000 as the population. And if it's doubling every so often, I would be using 2 as the base of my exponential. But I don't want the doubling to occur until 75 years. In other words, every 75 years is when it should be doubling. So I'm going to put raised to the t over 75. This t over 75 right there will cause the period of time that it takes for the doubling to occur to be stretched way out instead of annually, right? If I put t, it would mean every year we doubled. But when I do t over 75, it takes 75 years for that exponent to reach the value of 1 and to actually double. So that is going to be the function that represents the scenario. Now what I'm going to do though is go backwards in time 300 years. So I really need to then solve this for t equals negative 300. And so that's what I'm going to do. I'm going to do p of negative 300 because that would be the year, right? This 240,000 was in the year 1959, but I need to go back 300 years. So it's going to be 240,000 times t raised to the negative 300 over 75. So I'm going to do that. 240,000 times 2. And then we'll raise that to the negative 300 over 75. And there's my answer. The population back in 1659 was 15,000. That's the correct answer. I want to show you number 17. I found this a little bit unique in that it does give me 3 ordered pairs for a quadratic function. And normally what we would do is we maybe would go over to Desmos and do a regression. It's just that if you do run the regression over here, it is not going to give the equation in this format. So really the easiest way to do this problem is to use one of the ordered pairs. We'll start with 24. When x is 24, we expect an output of negative 8. Well, if I stick a 24 into this function, that 24 will make this 0, which will then make this entire product here 0, and my output would be 4 instead of negative 8. When I get to answer B and I plug in 24 for x, it does knock that out and it gives me an output of negative 8. And so B is going to be my answer. If you try these other answer choices right here and plug in a 24, you'll see that you're not going to get an output of negative 8. I want to show you, though, one other thing that you could do. I want you to understand that you can use Desmos in what we call a customized regression. So if I do put these ordered pairs into a table, and I run the regression by clicking the regression button and selecting quadratic, you will see that it gives it to me in that format right there, in what we call standard format. But what you can also do is you can do a customized regression. What I can do is say y1, I'm going to use my variable y1, that's my variable in the table, and I'm going to use a tilde. If I've ever coached you on the SAT, there's a good chance I've shown you customized regression. I don't think I show this to all of my students. It may not come up. But on your keyboard to the left of the number 1, if you do a shift and you bring up that tilde right there, that's what's telling Desmos to do a regression using the values for y1. And what I want to do is I want to make this equation look like the format that they have here, which is kind of a modified factored form. And so what I'm going to do is I'm going to put in here x minus a times x minus b, and then I'm going to try, and this has to be x1, and this would have to be x1 because my variable is not x, it's x1. But if I put a plus 4 right there, it doesn't give me the numbers 24 and 30. Let's change this to a minus 8. Okay, it does give me 30 and 24. So that's probably not the best way to, I know that's not the best way to do this problem for sure. It really was, and I think most of my students did this, is they used this ordered pair and just plugged it in and see which one of those equations has that as its solution. I have had a few students miss number 18. It says a circle in the XY plane has a center at 19, 18. Well, all of my answer choices have the right 19, 18, negative 19, negative 18 to represent the center of the circle. They all only differ by this constant that's on the right-hand side. And that constant on the right-hand side of the circle equation is r squared. So what you have to do is you have to square the entire 9k, right? So it's 9k. If that's the radius, then you must square it. And so we expect to get 81k squared right there. I have had several students, more than one student, that didn't square the 9. They just squared the k and went with 9k squared. Now, the whole radius, whatever its expression is for the radius, the whole thing has to be squared. So answer B is going to be the answer for this. Take a look at number 19, because this is also a problem that definitely more than half of my students missed on the test. This says that the estimated total mass of M-type and K-type stars in the open star cluster is 127,882 quetagrams. The graph shown models the possible combinations of the number of N-type stars and K-type stars that could be in this open star cluster if all the M-type stars had the same mass and all the K-type stars had the same estimated mass. Based on the graph, which of the following is closest to the estimated mass of each M-type star? Well, again, the whole key here is that this line is representing all possible combinations of the two types of stars. And if you take a look at, one of the points, like right here, this says in this open star cluster that there could be 30 M-type stars, but if there are 30, there would have to be 110 K-type stars. So that's what this line is representing, all the possible combinations. Well, the combination that I want to use is this one down here at the x-intercept, because this is my number of M-type stars on the x-axis. That point right there, the x-intercept, that point says if there are about 157 of the M-type stars, there would be at the same time none of the K-type stars, because that point right there is 157, 0. That would mean that all of that mass, 127,882, 127,882, it's all in those 150 M-type stars. So therefore, I would go over to my calculator and divide the 127,882 by all 157 M-type stars. I get 814, and that's closest to 811. Okay, so that's what that problem was all about. Let's take a look at number 21. For a particular car, the linear function f gives the predicted power in brake horsepower for engine speeds between 1,000 RPM and 6,000 RPM. Okay, and then they give me two ordered pairs with these two variables. It says that the predicted power is 433 horsepower at an engine speed of 331, but 600 horsepower at an engine speed of 4,500. Then it says the equation f of x, 1/7 x minus a plus 433, defines f, where x is the engine speed in RPM and a is a constant. So the first thing that you want to do is recognize that it is a linear function and that there are two variables. right away you want to understand what's the y variable and the x variable. Now, they did tell me that x is the engine speed eventually, but as soon as you say that the function gives predicted power, that's your y variable. The function is giving outputs of predicted power. So I'm going to have power as my y variable, and then the speed, RPMs, we'll use that RPMs, that's going to be the x variable, right? They told us that eventually down here. Now, the interesting thing about this problem is the equation that they gave us only is missing one part, and it's this x minus a right here. And here's the key to this problem to get it very quickly, is you need to recognize that that right there is a modified version of the point slope form of an equation. In other words, one of the ways that we write equations of lines is by using this formula right here, where I put the slope in, and then I put one of the ordered pairs that's a solution to the line that's actually on the line itself. Well, take a look at this. They told us that the predicted power is 433 at a speed of 3331. That's the ordered pair 331, 3331, comma 433. So when I look at the equation that they gave me, I know what the 1/7 is right there. It's the slope of the line. I don't even need to calculate the slope of this equation. That's what it is. I just need to recognize that they used this point right here, and therefore they made the equation to be y minus 433 equals, apparently 1/7 is the slope, and then they would have had to have used 3331, because that's the x value that goes with the y value of 433 horsepower. But they took that negative 433 and moved it over to the other side, giving me y, or f of x, equals that equation. So my answer here is 3331. It really takes no calculations at all. You could have just recognized that it was point slope. And again, this is question 21, so this is designed to be a pretty challenging question. Now, could you have done this in Desmos? Probably, because they did give you two ordered pairs. Okay, but you would have had to use a custom regression, because that's not the format that their regression is going to spit your equation out. They're going to spit it out in y equals mx plus b form. And that wasn't the form of the equation that they wanted you to use. So that was the challenge there. And then number 22, it says, how many distinct real solutions does this equation have? Well, I can divide both sides by 52. When I do set, and I would set each of these factors equal to 0. When I set that one equal to 0, I get only one solution, and that would be a -8. But when I set this equal to 0, I am going to get two real solutions. It should be a +3 and a -3. Remember that when you have an even root, in other words, you would do this, right? If you're going to find those other solutions, you would set that factor equal to 0. You'd have x to the 4th equals 81, and then you would take the 4th root of both sides, like that. But this is going to give you two separate answers, right? It's going to be a plus or -3. So I have 3 total answers here. Now, if you weren't sure and you had time left, because a lot of students do have extra time on Module 1, you could have, just to be sure, quickly graphed this equation. Now, I tell my students that if you are going to use Desmos to solve an equation, what you want to do is graph the left and right hand side. So I'm going to graph the left hand side as a function, y equals 52 times x to the 3rd plus 64. I think we're going to be able to see this. Maybe it may be a little bit tough, but, and then I'm going to graph that. And then you graph the right-hand side, which in this case is y equals 0, which is just the x-axis. But you can see that there are 3 intersections between the left-hand side graph, right? There's 3 intersections here. And so that means there's 3 solutions. You could zoom out and see if there's any other x-intercepts, right? There's not. And you can't see the top of this because these numbers are going to be so large, but they look like vertical lines, but they really don't. If you kept going up and up and up, you would finally get to the top of where these functions turn and come back down to the x-axis. But I can see that there are exactly 3 real solutions, x-intercepts, on the graph. Now I'm going to work some of the problems from Module 2 that the students that I've been coaching leading up to this March 14th SAT that have most often missed on Module 2. And this is the more difficult Module 2. So as you all know, I think you all know that after you complete Module 1 of the math section, their algorithm will determine whether you are going to be moving to the harder Module 2 or the easier Module 2. And you most certainly want to be put into the harder Module 2 because you want to score well enough to prove to the algorithm that you are ready for the harder problems. And then you have the ability to get your score well into the 600s. If you do poorly on Module number 1 and you get put into the easier Module 2, then you really have capped your score at about a 600, no matter how well you do on that easier Module 2. So everything that I'm working here comes from the harder Module number 2. The first one that I want to look at here is number 6. It's a very straightforward problem, but I did find several students that did end up missing this, and they really regretted it because it's an easy problem, right? It's number 6, so we expect this to not be too challenging. This says 7 times f of 2. I had students say, well, I wasn't sure what that 7 meant there. It's a 7 times, right? So you have to do f of 2, which would be 8. So this is 7 times 8. And then g of 2 is 12. So it's 56 minus 12, which is going to give us an answer of 44. Very straightforward. So point is, don't miss parts of the expression there. Be sure that you're looking at everything and interpreting everything as you should. All right, number 7. A circle A in the xy plane has the equation here. Circle B has the same center as that, but the radius of circle B is 2 times the radius of circle A. So here's circle A, and with that 25 there, you know that the radius is the square root of 25, or 5, which would mean then this other circle, its radius is twice that. So this other circle has to have a radius of 10. So therefore, that has to be r squared 100. So your answer here is 100. So students that miss this maybe forget that when they're working with these circle equations in the xy plane, that this is not the radius, right? It's the square of the radius. So you have to square root it to get to the radius, and then you have to double the 5 to make 10, then square the 10 to find that constant for the other circle. All right, I'm going to show you this one here because I had, I'd say maybe a third of my students miss this. And the lesson learned here is that you want to do things quickly, but you can't do them so quickly that you overlook an important part of a problem. They wanted to know what the value of A is, and they saw that, that's the coefficient that's in front of the x squared. And then students looked at this part right here and said, oh, well, that's 5x squared minus 3x squared. So therefore, A must be a positive 2, 5 minus 3. And they went with this. But they forgot that before you can combine like terms, you've got to be careful to remove the parentheses. This 5x squared, when you distribute that minus that's in front of the parentheses, it actually becomes negative 5x squared. And then that minus gets distributed and it becomes minus 3x squared. So it's actually a negative 8 coefficient because I have a negative 5x squared minus 3x squared, negative 8x squared. That coefficient has to be a negative 8. So again, you have to show or exercise caution to not make I would say that's kind of not a silly mistake, but it's one that's caused by rushing and not looking at all of the steps really that you need to go through to get the right answer. I've had several students miss this, and This says that the shaded region shown represents the solutions to the inequality r times y is less than 60. Now, here's what I coach my students to do in a situation like this. If ever I am given a graph of a linear function or a linear inequality, or maybe they describe a linear function or linear inequality with the words, or they give me some ordered pairs, and then they tell me to find some characteristic, a y-intercept, an x-intercept. I tell my students, look, just go ahead and ignore this for right now, and you use your knowledge of linear functions or inequalities and come up with the proper inequality for the problem. This line, this boundary line, is at x equals -4, and it's shaded above. So that would be the inequality y is greater than -4. That is what that inequality, the shaded region, is. Y greater than -4. Notice it is a dashed line right there, so it's a greater than. Okay, then now compare what the reality is of what the graph is telling you to what they're telling you that the inequality is. And the thing that you notice when you compare the reality of the inequality from the graph to the one that they're presenting is that the inequality is in the wrong direction for ry less than 60. So what that tells me is this r that they want me to choose has got to be a negative number that would cause that inequality to flip to become a greater than. So that if that is a negative number and you divide both sides by r, you will get y is greater than 60 over r, and it needs to be a -4, so you can see that it's going to have to be a -15. So I think the most often wrong answer chosen was the 15. No, you have to flip that inequality, and that's going to happen by using a negative value for r. Okay, let's move on. Number 13. The histogram summarizes data set A, which represents the number of points per player earned by 50 players of a game. A new player earns 18 points playing the game, and this number of points is added to data set A to create data set B with 51 values. Which of the following must be true? Well, the 2 points that we have to evaluate here are whether the median of B is less than the median of A, and whether the mean of data set B is less than the mean of A. Well, here's the thing. Data set A is what we're looking at right there. Data set B is made by just simply introducing this other player into the data set who scored 18. So they would have then shown up as one player in that bar there between 10 and 20. Now, one thing that we know about averages or means, if you put an outlier into a data set and recalculate the mean, you are going to change the mean. So there's no doubt that Roman numeral 2 is true. The mean number of points for data set B, which includes the outlier here, is got to be less than the mean for data set A, which was without the outlier. So definitely that is true. But the question is, does the median change? Does the median become less? Well, here's the thing. If you have taken a stats class, you know that medians may, or I should say outliers, may or may not change the median of a data set. For example, if I show you the following data set of 5 numbers, the median is 8 right here. But if I introduce an outlier of 27, what happens is the median becomes the average of those 2 middle numbers right there. And so the median does not change. It stays as an 8, even though I just put an outlier up on the high side. Now that outlier right there is definitely going to increase the mean value, right? Whatever the mean was here, it just went up as soon as I add that extra point, 27, but the median did not change. So what do we have to do? Does the median change? Well, what I'm going to do is make sure that I know where the median is in this chart for data set A. When n is equal to 50, What I can do to find the location of the median of a data set is take the number of things that are in the data set, add 1, and divide by 2. That tells you how far you count from the low end to get to the one data set or one data point that's in the middle. That's the median. Well, in this case, that would be 51 over 2, which is 25.5. Now, what that tells me is that I would have to find the 25th and the 26th player, their score, and average them together, and that would give me the median for data set A. Now, then I'm going to look at this histogram and determine where is the 25th and 26th player from the bottom. Well, there's 4 players, it looks like, between 30 and 40. It looks like there's about 7 from 40 to 50, and this looks like there's about 27 here, and maybe 12 between 60 and 70. So if I'm looking to see where the 25th and 26th from the bottom is, it's clearly going to be in this stack right here of all 27 of these players that were between 50 and 60. Because here's my bottom 11, and then this would be the 12th through the 38th player. And the 25th and 26th is going to be in that stack. When we add the extra player, there's now 51 players in the set, and 51 plus 1, right? N plus 1 over 2 is 26. So that would mean that the 26th player, and if you take a look over here, this would be my one player that I added. But if you add up to see how long it takes to get to the 26, right? I got 1 and 4 is 5 plus 7 is 12. Then player 13 through 39 is in that stack, and that's where the 26th is. So the median is still going to be somewhere in this interval between 50 and 60. So therefore, the median does not have to change. This does not have to be true. It says which of the following must be true. The median did not change stacks, so I can't confirm whether it did or didn't change. Doesn't have to change. So my answer after all that long explanation is, no, not this one. It's going to be just Roman numeral 2 right there. Okay. So the thing I want you to take away from this is, how do you find where the median is? It's going to be at n plus 1 over 2. That's how far you count from the low end till you get to the data point that would be in the middle of the data set. All right, quite a few students missed number 14. It says in the scale model of an office building, a length of 1 inch is equivalent to a length of 17/3 feet in the actual office building. If a length in the actual office building measures x feet, which expression represents the corresponding length in inches in the model in terms of x? Well, this is a pure proportions problem. I have a scale that says 1 inch is equivalent to 17/3 of a foot. Therefore, I'm going to set that equal to another ratio. And they're saying that it's x feet. So since this is feet down here, that would have to be x feet. And it says, which expression represents the corresponding length in inches of the model? Well, that's going to be up here. And I'm going to give that a variable z. I'm going to solve this proportion for z by cross multiplying. 1 times x is x. Z, the thing that they want me to solve for, is multiplied by 17/3. And again, they wanted me to solve for this. So what I'm going to do is multiply both sides by 3/17. Those will multiply out to be a 1. And there's my answer. My answer is 3x over 17. So that one right there. Now, I had several students, probably 25% of my students, thought that they needed to introduce this conversion on 12, or that they were supposed to put 12 inches up here. No, this problem had nothing to do with the fact that 1 foot is equivalent to 12 inches. Okay, in fact, had nothing to do with that, because this was scaling feet of an actual office building to the inches of a model for that office building. So therefore, the only equivalency that was involved was the fact that 1 inch is equivalent to 17/3 of a foot. This did not need to get put into this. So A and B are definitely going to be out. And there's going to be my answer right there. All right, let's look at this one. In the given equation, P is greater than 1, T is greater than 1. If T is equal to P raised to the 3n minus 1, where n is a constant, what is n? Well, I have two equations here. So what I'm going to do, since this has T isolated, I'm going to isolate T on this one so I could then set the P's equal to each other. So let's take this equation. I'll convert that radical to P to the 2/3 equals T to the 9/7. To solve that for T, I need to raise both sides to the reciprocal power of 9/7. So I'm going to raise this to the 7/9 on both sides. That'll give me T to the 1. And here, when I raise this power to another power, I will multiply here. It's going to be 14 over 27 when I multiply those two fractions. All right, so then what I can do, since T is equal to this, and according to this, T is also equal to this P to the 3n minus 1, I will equate those to each other. P to the 14/27 is going to be equal to P to the 3n minus 1. And we taught you in Algebra 2 that if you have an exponential equation and you've matched the bases on either side of the equation, then you can just simply equate the exponents. And now I'm going to solve that equation for n. And I'm going to let Desmos to do this work for me. I'm going to do 14/27. I will add 1, and then I'm going to divide by 3. And there's my answer. If I convert that to a fraction, n is 41/81, and that's our answer right there. If you converted that to a decimal, that's fine too. You could have answered 0.5061. All right, let's move on. All right, this is a great question because this is a theme that you do see repeated on many SATs. They give you an equation and there are missing parts to it, right? A and B are missing. Those are constants. And they want me to find B, the constant B right there. Now, what they gave me are two ordered pairs. They said that the graph that we're looking at, or the graph of the equation that we're looking at, passes through this point, and that's also another solution. So what your job is here is to always take the solutions that they give you, and we have two of them, the 0, 22. That one is just the solution -22, 0. What I'm going to do is I'm going to plug these points into the function and then see what happens, right? That's going to allow me to solve for A and B. So if I stick this point in here, I get 22. That's my y value, so it goes in for g of x. And then when I stick a 0 in for x, all that I have is -a over -b, right? Because the x's are going to get removed when I stick a 0 in for the x's. And this tells me that 22b is equal to a. Because the minus over minus will become positive, and I can multiply both sides by b. And they want me to solve for b, so I do know that b will be a over 22. So I need to find out what a is, so I could divide it by 22, and that's going to be the answer I need. And I would have to assume that I'm going to be able to figure out what a is by plugging in the other ordered pair. So I'm going to plug -22 in for x and 0 for y. And this is what the equation looks like. 0 is equal to -22 squared minus -22 minus a all over -22 cubed minus a -22 minus b. All right, now, if you go back to Algebra 2, or even if you're in AP Pre-Calc, you worked with rational functions. And one thing I know about rational functions that is fractions that have variables or unknowns in them, if it's set equal to 0, it's the numerator that I need to set equal to 0. What makes this function equal to 0 is whenever that numerator is 0. So really what I'm solving here is 0 equals just the top part. I don't really have to worry about this bottom part. So this is going to be negative 22 squared plus 22 minus a negative 22 minus a. Well, I'm going to bring that minus a over to the left, and that tells me that a is negative 22 squared plus 22. Coming over to Desmos, I'm going to do negative 22 squared, and I'm going to add 22. I see that a is 506, and up here, I know that the b that I was trying to solve for is a divided by 22. So I take the 506 divided by 22. I get my answer, 23. There we go. I'm going to work 2 more problems from this practice test. I'm going to work number 21, and it gives me a graph of a function called g of x. But then it tells me that there's an equation, g of x plus 28. And what you have to know is that when you take a function g and replace x with x plus 28, you're doing a horizontal shift left 28. So what would happen is this whole graph is going left 28, which means these x-intercepts that are located here are all moving left 28. So if I drew my own sketch of this graph, that negative 2 is going to come over and be negative 30. The 1 will be a negative 27, and the 3 will be a negative 25. That function is the same function that's going to bounce here, turn and bounce, and look like that. So I have 3 new x-intercepts. Well, we know that x-intercepts are what make the factors of the polynomial. So that would mean then that this function that was just shifted to the left would have to look like this. It'd have to be x plus 30. It cuts through minus 30, so it has a multiplicity of 1. It bounces at negative 27. That would be a factor of x plus 27 squared. And bouncing here would be x plus 25 squared. And so I can see the 2 squareds, which are the a and the b, and I don't know which is which. That means then that b would be either negative 27 or b could be negative 25. And the answer choices, the only one of those that appears in my list of answers, is the negative 25. All right, and then I want to wrap this up by showing you how I would work this percentage problem number 22. I tell my students when it comes to percentage problems, if it's a percentage of statement, percent means out of 100, so I'm going to put 468 over 100, and the word of means multiply, and the word is means equal. So the way that I tell my students to work all percentage problems is you have to convert the expressions of the percentages into equations, and you make it into a system of equations. And I'm going to do that. I'm going to actually write 3 separate equations as I read this paragraph. It says the weight of sample A is. So I'm going to use the weight, WA, weight of sample A, is 468%. Well, that would be 468 out of 100. That percent symbol means out of 100. Of the weight of sample B. That means times the weight of sample B. Right? Of next to a percentage means to multiply. Now, I'm going to change this to 4.68, right? You and I know that that is a 4.68. Then, comma, the weight of sample A is 0.78% of the weight of sample C. Well, that's 0.78 over 100, which would be 0.0078 times the weight of C. And then even the question that they give me, I'm going to convert that into an equation. it says if the weight of sample C is P percent, that would be P out of 100 of sample B, what is P? There you go. It's 3 equations to be solved. So what I'm going to do, first of all, I can notice that I can set those 2 equations equal to each other because they're both equal to the weight of sample A. So therefore, the first thing I'm going to do is equate that. 4.68 times weight of B is equal to 0.0078 weight of C. Well, I'm going to divide by 0.0078 on both sides because I want to know an expression for the weight of C so I could plug it into the third equation. So coming over here to Desmos, 4.68 divided by 0.0078 is the number 600. So that means then that the weight of C is equal to 600 times the weight of sample B when I divided both sides of that by 0.0078. So then all I have left to do is to do a substitution of 600 times WB into that third equation. That third equation becomes 600 times the weight of B is equal to P over 100 times the weight of sample B. And what happens is the WB, the weight of sample B, is going to divide out on both sides. If you divide both sides by weight of B, it divides out. I solve for P by multiplying by 100 on both sides. And 600 times 100 is 60,000. And that is the answer to that question. Okay, students, I hope that was helpful. I didn't work all of those problems on the hard module 2, but I did the ones that really most of my students struggled with, and I hope it was helpful to you. And I will be here every Sunday night. Tonight was a recorded session that's streaming live, but I did pre-record it. But every Sunday night at 8 p.m., I will be here for the rest of the school year, except for probably spring break week in a couple weeks. But do come back to the YouTube channel at 8 p.m. on Sundays. I will take live questions. If you have homework questions, you can send them to me, and I'll work those. Most weeks I have an opening 15-minute segment where I will talk about maybe the ACT or the SAT or some topic for the week. But then after that, I take questions. All right, everybody, have a great week. If you're taking the SAT March 14th, I wish you all the best of luck. Talk to you soon.